So now we're going to be looking at cumulative probabilities for binomial distribution. So here we have an example. We know that x is binomially distributed, we're running 20 trials and the probability of success is 0.4. First of all, we're asked what's the probability that we have 7 successful trials out of 20. We did this in the last video, so we can come along with our calculator. We're going into the menu, we're pressing option 7 for distribution, and then I want x less than or equal to 7, so this is going to be binomial CD, cumulative distribution. I want a variable 2, my x value is 7, my number of trials is 20, and then my probability is 0.4. And then I'm told the probability of x being less than or equal to 7 is 0.416. Now my next question asks me, okay, what's the probability that x is less than 6? So this time I want the probability that x is less than 6 but not equal to 6. My calculator can't work this out for me. My calculator can only do less than or equal to probabilities. So if I wanted the probability that the number of successful trials is less than 6, then I want 5, 4, 3, 2, 1 and 0. So I can rewrite this problem as the probability of x being less than or equal to 5. So if it's strictly less than 6, because we have a discrete variable, then it means that we want equal to 5 or less. And so now I can use my calculator in the same way I did for the previous problem. And I just need to change my x value now to be in 5. Everything else remains the same, and I get 0.126. Done. And then lastly, I want the probability of x being greater than or equal to 15. So I want 15 or more successful trials. So I want to know what's the probability that I have this many successful trials. Again, my calculator can only do less than or equal to, so I'm not going to be able to work this out with my calculator. However, I could work out the probability that I have 14 or less successful trials. So if these trials are all successful, and because my probabilities add to 1, so it means the probability of this many trials being successful plus the probability of this many trials being successful will be equal to 1. I can say this here is the same as 1 minus the probability that my number of successful trials is less than or equal to 14. So again, if I go back into my binomial distribution, I want less than or equal to 14. And so I know this thing here is 0.998339. And then to do 1 minus this, I'm going to have to go back into my normal calculator setting. 1. And so I want 1 minus 0.99839. And this is 0.0 minus 3, 0.0016. So whenever you get a probability that isn't an x less than or equal to, if you get something else like this, you need to change it into an x less than or equal to probability in order to work it out. I've got some here for you to have a go at. These 3 here are the same as the ones here, so you might be able to use that to help you. But then you might have to think a bit harder for these ones. Pause the video now and have a go. And here are your answers. The first one's very straightforward, so that's the same that you can use your calculator function. Less than 3 is the same as less than or equal to 2. Greater than 2 is going to be 1 minus the probability that x is less than or equal to 1. And then we have the probability of x being less than or equal to 10. You can just use your calculator again. The probability that x is greater than 6. This is going to be 1 minus the probability of x being less than or equal to 6. Probability that x is equal to 5. You'll need to go back in and use your binomial PD function on your calculator for that one. And then this one here is the hardest. So the probability of x being between 2 and 7. Well, if you look at the probability of x being less than 7, you can use your calculator to work out this probability here. Once you've got that on your calculator, then if you remove, we want x being greater than or equal to 2. So what I need to do is I need to get rid of these two here. And so if I take this probability and I subtract the probability of x being less than or equal to 1, then I will be left with the probability of x being between 7 and 2. Okay, next example. So this time we have a worded problem. A spinner is designed so that the probability it lands on red is 0.3. Jane has 12 spins. Find the probability that Jane obtains no more than 2 reds and at least 5 reds. So this time we're going to have to build our binomial distribution and also write our problem. So x is binomially distributed. My number of trials here is going to be 12. My probability of success is 0.3. I want the probability no more than 2 reds. So I want the probability of x is less than or equal to 2. And then we can use my calculator. So I want 7. I want less than or equal to, so I'm going to have to use CD. I want a variable. My x value here is 2. My number of trials is 12. And then my probability of success is 0.3. And so I have my probability is 0.2763. And then I want the probability that I get at least 5 reds. So I want x to be more than 5 or equal to 5. So it's greater than or equal to 5. And so now I need to change this into a less than or equal to probability. But if I want, I can do 1 minus. And if I want x to be greater than or equal to 5, I'm going to have to take away all the things that are below 5. So I want x less than or equal to 4. And then you can use your calculator to work this out. And you get 1 minus the probability of 0.7237. And then this is equal to 0.2763. And we're done. You have one here to have a go at yourselves. So a particular type of plant, 25% of your plants have blue flowers. A garden centre sells the plants in trays of 15. A tray is selected at random. Find the probability that the number of plants with blue flowers is exactly 4, at most 3, and between 3 and 6 inclusive. So that means we're going to include the 3 and the 6 here. So to state your binomial distribution, state these problems in terms of P, X, and then work out your probabilities. Pause the video and have a go now. Here's your binomial distribution. Number of trials 15. The probability you have blue flowers is 0.25. You might have written that as a fraction, also fine. And then you want the probability that you have exactly 4 plants being blue. The probability that you have less than or equal to 3 plants being blue. And then the probability that your number of plants is between 3 and 6 is the same as the probability that your number of plants is less than 6 minus the probability that your number of plants is less than or equal to 2. And we're done.